Good day folks, we've got a Omax Waterjet. Today we're going to go over how the abrasive delivery system works. A Waterjet works with a combination of water and the abrasive. The water and the abrasive mix together under very high pressure, 50,000 psi in this case, and that pressure erodes through the material. It doesn't cut through material, it erodes through material in the exact same manner that a river cuts through a mountain. It's the exact same process. The river and the sand in the river cut through the mountain. In our case, we're using the sand and the high pressure water to abrade through virtually any material, whether it be glass or steel or aluminum, ceramics, virtually anything. So we'll go through the abrasive system, how it works from beginning to end. Bear with me, some of it is mundane, and we'll see how see if I miss anything. With virtually every shop, we have to start with good clean air. In this case, I've got a Ingersoll Rand compressor I bought probably near about 6 or 7 years ago now. It's a little single cylinder. I think it's 15 or 16 cubic feet per minute. Don't quote me on that, but I believe so. A little motor is only 1.5 horsepower or so. I haven't had a whole lot of trouble with this compressor. It's been pretty good to me. As far as maintenance goes, the only thing that I've done to it is replace the air filter a few times. We changed the oil a few times. Special compressor oil. There's a sight glass here to so we can keep an eye on it. This compressor uses very little oil. So I very seldom have to top it up, and maybe every 6 months or so. And as far as changing the oil, perhaps every couple of years. On this unit, my start capacitor exploded and ran oil down. So I couldn't find another capacitor that had the same case style, the same case size. So I just stuck this on temporarily, and it's been temporary now for like 3 years. And I still haven't got around to finding a smaller one to fit inside the case like it should. On this compressor, I've got it set up with three different systems. Over here we have just a regular flow for just for general air blowing through and so on, with a filter dryer. On this part over here we have a regulator and a lubricator for power tools. And this one we have a dryer with the desiccant in it. And we use that for running the Waterjet. The desiccant, I change it out every couple of weeks, I suppose. Just a matter of undoing the band here and popping it out and emptying the old desiccant out, replacing it with the new desiccant. The desiccant should be blue when it's dry, good to use, and it turns pinkish color when it's got too much moisture in it. The desiccant beads for the compressor, these are completely reusable. I've been reusing these same beads now for, oh my gosh, probably 4 or 5 years. When they turn pink, it's just a matter of drying them out. You could do that in an oven, for example. All I do is, I've got an old pot here from the kitchen. Dump the wet beads, the damp beads into the pot, and I put them on put the pot onto the wood stove, and within a couple of hours or so they turn blue, and then I can pour them back into the old container and reuse them. So I've reused these beads, oh my gosh, a couple of dozen times, I suppose, and I guess they will get contaminated with oil eventually or so, but right now they still seem to be doing just fine. Okay, still going on about the air system. Waterjet must have air. We've got air coming down through those red lines from the compressor, from the manifold up there, which you can't see. They come down along the floor into the Waterjet manifold, which is right there. You can see the regulator there, air regulator there. That regulator is set at about 70 psi, as I recall. In a moment, is it? No, I don't have it marked. I'll leave it at 70 psi. And those control, that regulator controls the various pneumatic valves on the system. So again, the system is very simple. It's just a regular sandblast hopper with this addition here to allow the sand to get pushed through this T-fitting here, which is just a standard, looks like half-inch pipe thread, galvanized steel T-fitting. So the sand drops down into this area, the air blows it through into the plastic hose, and then it goes into the next hopper. Now, still with the hopper here, on the side of the hopper we have a drain, just to if we want to empty the air out of the hopper quickly, we can open the valve. That would allow the air to drain out from the hopper, so it's not under pressure any longer. Inside the hopper, we have the abrasive. Once we fill the abrasive through the hole here, you'll see a little rubber piece all around here, and you can see the rubber piece right there on the plug, and the plug pulls up, the air pressure pushes from the bottom, and that will force the rubber against the rubber to make the airtight seal such that it maintains the 40 psi. The sand itself is just regular garnet sand. This is just a regular piece of sandpaper. You see on the back of it, it says garnet. That's all this sand is, the exact same stuff. This sand comes from Barton. I buy that in the 1-ton tote. Each tote is 2,250 pounds. There's 40 odd sacks. Each sack is 55 pounds. 80 grit. HPA is just their designation for a Waterjet. For filling the hopper, it's not quite as easy as one would think. Consider that the sand must be very, very pure, and I'll explain that as the system goes along. But any debris of any kind, any bits of paper from the pack here, any sawdust or anything like that, will plug up the air line and the delivery hose, and it'll once you get a plug in the system, it's very difficult to trace it through. I keep a very sharp knife right here in this little cubby hole to empty the sand from the bag into the hopper. It takes 12 bags to fill the hopper up. Again, it seems really, really basic to be telling you guys things like this, but it's incredibly important that absolutely no debris gets into the hopper at all. So for example, have a look around outside your bag to make sure you don't have any debris of any kind. I mean, absolutely nothing. Now, when you're tearing the bag open, if you just tear it open willy-nilly, you're going to get small bits of paper into the hopper. If that happens again, it's going to plug the system up, and you're going to have a hell of a time to find out where the plug is, where it happened, such that you can clear it. The best way I find to open these bags, again, very, very sharp, razor-sharp knife, and do one quick slice around across the top of the bag to make a very clean cut, not jagged at all. So basically, and a very quick. That's exactly what not to do. Yeah. See, I didn't have it right there, so I've got a jagged tear here. See, it was very good there, and then I messed it up at the end. This is what's not to do. So we'll try and salvage it here. So very, very carefully pull it back. Have a look inside the sand to make sure that no bits of paper have got inside. Lift it up and toss it in. Lift the bag up well clear so the sand doesn't go on top of the paper like that, because when you pull it up, bits of paper will break off in the sand and you won't see it because it's stuck underneath the sand. So shake the sack out, toss the sack away, smooth your sand out, and the sand will go down. Okay, see the sand going into the hopper. So we'll seal it up, and we'll turn our air on right there. Okay, so the air is starting to build up. Now this is important down here at the bottom at the clear plastic tube. Okay, you see the sand moving through the tube? You see that right there? Bang, 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 like that. So the air is pushing the sand through the clear plastic tube. The clear plastic tube goes all the way. On this case, I've got the hopper on the opposite end of the water jet. Clear plastic tube goes all the way around, in behind the water jet, through to this hopper. Okay, this hopper. The clear plastic tube. See the sand running down, and it's filling up the hopper. So you see the sand coming into the hopper. Okay. This hopper is only 20 pounds. And it will only last me about 20 minutes of cut time. So you can imagine how difficult it would be to be filling the hopper with sand every few minutes. It's very, very difficult. You know, you'd miss it once in a while and so on. So see how the sand is filling up the hopper, and it's self-feeding all by itself. Now we're going to wait a couple of minutes here, and we'll see as the sand rises, the sand will touch the bottom of the filling hose, and then it'll block itself off, so it'll self-regulate. So it'll as the sand drops down, the more sand will come in to fill it, and then when it fills up, it'll stop it all by itself. So it's an ingenious system. There's no valves, nothing to go wrong, impossible to fail. It'll self-fill all by itself. So let's wait a moment here, and we'll see the sand stop here momentarily. Okay, see how it's blocked itself off? So the hopper is now filled. And when it gets low, it'll refill itself all by itself. Okay, so now we got sand to the hopper. That's all fine and dandy. But now let's look at what happens after that. Which normally is up like this. There's this black shield is just to stop the water from coming up and splashing into the sand. It's incredibly important that the sand always remains dry. It must remain absolutely perfect dry. Even if it gets damp just the slightest little bit, damp sand or wet sand won't flow. So it'll just plug up the system, and you must clean it out to get dry, clean sand through the system again. So you must not let the sand get wet. So Omax have designed a little cover to go under, just so nothing splashes up and gets the sand wet. We'll take the cover off for demonstration purposes here. Okay, now this part here is the pneumatically driven valve to open and close the sand valve right in here. So we're going to take that off temporarily. See how the sand pops out. We're going to put a punch in there temporarily just to block it. Well, we give you an idea what's happening here with the sand valve. Okay, so here we have on the top half we have the pneumatic cylinder. Then on the bottom half we have the actual valve part. Right in there, you can barely see that. There's a little rubber plunger that seals off the sand that flows through. This part right here, that part right there, regulates how much sand is coming through the system. Now, let's go over here for a moment. This is the sand delivery abrasive orifice. Okay. This one is a little bit larger because I wanted to try different orifices. So all that is a 1/2 inch pipe thread, and actually this outside diameter is 1/2 inch, and the inside hole here, in this case, it's 0.77 inch. This size hole, and sorry, not 0.77. It delivers 0.77 pounds of sand per minute, that size hole. I don't know, it looks like about maybe a 5/16 hole, something like that. So that one will deliver 0.77 pounds, this size hole. Okay, on the water jet here, you can see this hole. Oh, it's pretty hard to see, I don't know. That hole is slightly smaller than that hole. Okay, so the original, this is the one that came with the water jet originally. It flows oh my gosh, about 0.7 pounds per minute of sand. I tried a little bit larger orifice to try to flow a little more sand to see if I would get any better quality of cut. And I found that nope, the original factory one was actually better. So you can, for different applications, you can get these different size orifices, or just buy a small one and drill it through yourself type thing. You know, like imagine if we bought that from the manufacturer, that's probably $50 or $75. You can make something like that on the lathe in 10 minutes and save yourself $75. And you know, have a few different ones for different different experimentation purposes and so on. On this machine, the way it's set up, it runs about 0.7 pounds of sand per minute. Okay, so after the sand comes in through the hole here, the valve, the pneumatic valve opens, the machine automatically opens it. There are timers on the machine, on the Waterjet, on the computer, that will open and close the valve at a certain delay after the water. So the water starts first, and then I believe it's set at 0.2 seconds. After that, the flow of the sand starts. And of course, it's important that the water starts first, and then the sand starts, because we don't want the water backing up into the the sand channel. And of course, wet sand won't flow. So it's very important that the water start first as it goes through the system. Now, on the bottom here is just a clear plastic hose. This hose will wear out frequently, about every 30 hours or so. I'm going to put this back in. Like so. Cover back in like that. Now, the hose here, the sand delivery hose, it wears out right in here, right in this spot right here. And that's because as the Waterjet fires, the water bounces off the material and it comes back up and it strikes the sand hose here and abrades it out. Also, keep in mind that, again, I keep going on and on, the sand must be perfectly clean and perfectly dry. Keep in mind that all of that sand from all of those pallets, and I've gone through, oh Christ, I don't know, 50 or maybe even 100 pallets of sand, thousands and thousands of pounds of sand, maybe even over 100,000 pounds of sand has gone through, maybe even 100,000 pounds of sand has gone through the system, always going through this little tiny hose. So if you can imagine that 1 ton pallet of sand every week or every month or so that we go through goes through this little tiny hose. And again, the hose needs to be replaced on occasion. If you're finding that your sand keeps blocking up, for example, there's a good chance that the hose has become so thin, and the suction and the maturity of the in the system here, I'll explain in a moment, causes the hose to collapse internally. So to replace the hose is very, very easy. I find the hose in these I don't know, 500 foot or 100 foot coils. And again, this is special hose. It's not just off the shelf hose. It's very, very tough stuff. We peel back some of it, measure out whatever the length is. That looks about right. Very, very sharp knife. There we go. We make sure that the hose does not have any serrated edges on it. It's a very clean cut, such that the sand will go through. On the OMAX systems, there's a larger hose and a smaller hose. One fits just inside the other. And the larger hose, I've got a spare bit here as well. But this original hose here, I've had this on the Waterjet since new. It actually hasn't worn out as yet. You can see the difference in color, how old it's getting here. But it's doing just fine. This is my used one here. So the smaller hose fits inside the larger hose. And let's put the system back together. It's in the bottom like so. Put the shield back on. Put the hose back on the mixing tube. Now the Omax engineers are pretty smart people. Now they've figured this out such that we can't, it's very difficult. I can't say we can't, but it's very difficult to make a mistake. You notice that the way the mixing tube is set up here, sorry, this is just a splash shield. It goes down like this, such that as the water comes out of the nozzle, it doesn't splash all over the place. We can take that off for the time being. Omax has set this up such that the alignment of the nozzle here, the abrasive hose is right out the back of it. So we know that if the alignment is not correct, that means we don't have this on correct. We don't have the nozzle in the correct place. Now, while we're here, we'll discuss for a moment how the Waterjet works, but we'll go into details of that in another video. This is just a talk about the abrasive part of it. The high pressure water comes through the stainless steel hose here, through here. This is a on-off actuator valve, again air powered. So it turns the water on. The water shoots through here, goes through here, goes through here. Inside here is a venturi, so it pulls the sand in through vacuum. The sand and the water mix right in here, and then the sand and the water mixture goes out through the nozzle into the materials being cut. Now it's very important that we get the height, or sorry, the distance between the end of the mixing tube here and the work to be cut has to be at a finite distance, and that distance is 60 thousandths of an inch. So I've got a little homemade feeler gauge that I put between the work and the end of the nozzle, such that I get that distance correct. Now 60 thousandths is a pretty small amount. If the distance between the mixing tube and the work is too great, that will make a poor quality cut with too much of a kerf and too much of an angle to it. If the nozzle gets too close to the material that's being cut, it partially blocks it, and it doesn't allow the venturi to work properly, such that water from the nozzle backs up through the sand hose. So if you're finding, for example, that your sand is always backing up through your hose, another thing to look for would be to adjust your height here to make sure that the water has a good gap in between, but of course not too much gap. So let's take this off so you can have a look inside to see what the Venturio looks like. Okay, now up and under here, which you can't see, there is a filter. They call that a last chance filter. It's a little filter right up in here. This is because for any debris that may be in the water line, it stops it at that final point such that it protects the pieces inside the nozzle. So let's go over the nozzle quickly. Okay, this is what the nozzle looks like. You can see where the sand goes in there. There's a hose here, or sorry, a hole here. This is just a pressure relief hose, so as you unscrew it, it doesn't blow off in your hand, that the pressure will relief out of this hole just in case it's under pressure. Okay, through the top here, you can see what's called a mixing jewel. So we'll pull that out. All right, let's talk about the last chance filter. This little filter fits, we showed you in the machine where it fits, but whoops, yeah, well, yes, it goes in like that, okay? So that any debris that may be in the water will protect the jewel. So every time we change a jewel over, we also change the last chance filter just to make sure we don't have any damage. Okay, now this is the jewel. I'm running a 14 thousandths jewel, ruby, just because it's the most efficient way to cut on all the material that we use. You can barely see that in here, that little tiny piece of glass. That's actually a ruby in there. These are about, geez, $80, $90 a piece, these little rubies. Now this part is the mixing disc. You notice it's broken. So I didn't know it was broken before. So I would have found that out pretty darn fast when I tried my next cut. The new mixing disc, which we'll replace right now. basically it's a little bit smaller than a penny. What the size of the orifice is inside, I have no idea. Probably, I don't know, 20,000, something like that. So that's what it's supposed to look like. In this case, that one was already broken inside. Okay, inside the nozzle, we have the sand coming in, we have the water coming in this way, sand coming in this way, and that little chamber in there is where it mixes and goes out the nozzle. Now, here we have two mixing chambers. We'll get a close-up on this. Okay, now, this mixing chamber here is new. You see how nice and smooth that is, and nice and round that is, and so on. And the next mixing chamber is an old one that I replaced. And you see how it's become, it's not round anymore. You see how much larger the chamber is here? And if you look at the sides, for example, you see how much larger the worn out one is from the original one. And on the bottom, again, you can see how much larger and how it's not perfectly round anymore, whereas this is the new one, it's perfectly round. So these are again parts that need to be replaced on occasion to make the system run properly. So that's the new mixing chamber. So this one, it's starting to get worn a little bit, but it's not too bad as yet, so we'll keep it there. Again, these mixing chambers are about $200 a piece. If you can imagine all the sand that's running through there, thousands and thousands of pounds of sand is running through that little tiny chamber, so of course it's wearing the system out a little bit. Before we put the system back together, we're going to clean it out. You can see that. I'm going to clean the jewel off. Before we put the nozzle back on, we put a little bit of glue goop on it because it's a stainless steel on a stainless steel, and we want to make sure that we don't gall the threads. I put a little tiny bit in this side there. Doesn't take much, just a very little bit, just to stop the threads from galling. Okay, so we'll put the mixing chamber in first. I don't know if you can see that. The mixing chamber goes slightly below the level of the surrounding area there. Okay, and then the jewel goes with the ruby side up, fits in just like so. Okay, back over to the water jet. Okay, we're going to put this, we're going to make sure the last chance filter is in place. Let's show you that again, how that works. Last chance filter goes up inside here like that. And again, Omax has thought through very clearly, in order for it to be lined up correctly, the hole for the abrasive delivery is going to be facing directly aft. So in order to tighten this up, again, very, very light hand tight, just a quick snap, that's it. That's all it's needed. It's not a reef or a slow, it's just a quick snap, and that takes care of it just fine. So I'll put the delivery hose back on. Yeah, where is it? There we go. Okay, and we'll put the guard back on. There we go. All right, a few other bits and pieces. We were talking about the air actuated valve for the sand right in here. This is a spare actuator that I bought just in case that this one wears out, but I've never, I've had it for four years now, I suppose. I never had a need for it. Spare jewels They come in various sizes. For example, this is an AccuStream version. That's 15 thousandths. That's a 15 thousandths orifice. That's a 15 thousandths as well. There's a 14 thousandths there, for example. Yes, I'm running 14 thousandths. Orifice is not 15 anymore. I was running 15, but I was finding that with a 15 thousandths orifice on this particular machine, of course, yeah, a 15 thousandths orifice I wasn't able to get the pressure high enough at low RPM. I was having to run the machine too hard, so I cut that back to a 14 thousandths orifice, and I found I can run the RPM down at 13,375 RPM, much lower than the 1500, 1550 that I used to. Let's talk about mixing tubes for a moment. A bit off topic here. This is what a mixing tube looks like. And this particular mixing tube, for example, marked on it, I got 111 hours out of that mixing tube. That's absolutely incredible. This mixing tube, for example, I only got 18 hours out of that one. Now, I want to show you these up close. Okay, have a look at the difference in diameters here. Now you look at the little tiny hole in the end of these. You can see that this hole is twice as big as this hole. So you can see with the 111 hours that I got out of this one, I've eroded the hole quite a bit larger than the other one. Now let me show you one more here that's quite interesting as well. This one right here. That was 56 hours I got out of this one, and you see what happened with this one. Can you see that, how the hole is no longer, oh, it's pretty hard to see, it's no longer round. You see how it's gone, broke out the side, such that the jet will no longer be round anymore. It'll be this hexagon, sorry, not hexagon, rectangular shape, yeah? So you can see how we broke out the corner right here. So of course, once it does that, the quality of the water is no longer, quality of the jet is no longer any good. Okay, gentlemen, a few more words about the system. These nozzle guards. This is the original Omax ones. They're about $40 a piece now, I suppose. They only last about 30 hours before they wear out inside. And then the jet allows it to just blow out all over. These ones, aftermarket ones, I believe I got these from AccuStream, and they'll last much longer. This one, oh, been on there at least 100 hours, and it's starting to get worn, but it's not too bad. So the Omax ones, you know, they look pretty, they're yellow and so on, and they're nice and thin, but that's their downfall. They're just too thin, they don't last long enough, and it's just too expensive to keep replacing these consumable parts when they're wearing out. So we're always looking for solutions to make it more efficient. So these AccuStream ones, oh, don't quote me on that, maybe it's not AccuStream. Yeah, they're probably AccuStream. Are much better for longer lasting, but they're not nearly as nice to work with because they're quite a more heavier. They don't move as much, move as easily type thing. They're quite a bit stiffer. I tried using a toilet plunger, for example, and it lasted for maybe 5 hours, something like that. It was nowhere. The rubber is just not won't hold up to the abrasive action of the water and the abrasive itself, so it doesn't last with it in. Anyway, so these AccuStream ones are lasting much better than the Omax ones. Well, folks, I can't think of anything else to tell you in regards to the abrasive delivery system. In a future video, we'll go over how the water system works. You see the bulkhead there with all the fancy filters and so on. We've got a reverse osmosis system, lots of flow meters there, for example, all the auxiliary pumps under here, for example, for our rainwater collection system, how we use the rainwater off of the roof of the building to power the water jet, and then how we have to clean that water and treat the water and so on, such that it is good for the machine and becomes a very efficient way of doing things. We also, down here, we have 2 other pumps for recycling the cooling water back into the storage tank. Outside the window here, you can see the big 5,000 gallon storage tank that we always have full of water, which lasts us, my gosh, probably a month. That big tank lasts us. And for example, we'll go over in a future video how this tank here, which we put the water from the directly from the sides of the building, from the gutters, it runs into this tank, and then from this tank it goes through the RO system. From the RO system it goes into that storage tank. From that storage tank it goes back into the pressure pumps, through the pressure pumps, through all these filters and so on, to and we get the water down to 0.2 microns, these 20-inch filters, and those filters have been there for well over a year now. Well, you can see right there, you can see here the date, September 19th 2014 is when I replaced these filters last. So now that we're using an RO system, reverse osmosis system, we're finding that we're able to have much cleaner water, and hence not going through filters nearly like we were. So we'll go through all that in a future video. Okay folks, that's all I can think of here at the moment. Oh, the compressor's kicked in here anyway. So I'm going to shut down the system now, and next time we'll go over the water system, how that works on a water jet.